The ocean, teeming with life, is a marvel of nature. Its vibrant ecosystems are home to countless species, each playing a crucial role in maintaining the delicate balance of marine life. However, this balance is under threat, faces a growing threat: expanding dead zones. These are areas where the water holds too little oxygen to support most marine life. The lack of oxygen, known as hypoxia, creates a hostile environment. Fish and other creatures suffocate, struggling to survive in these harsh conditions. These dead zones are increasing in size and number, spreading across our oceans at an alarming rate. They are a stark warning of the ocean's deteriorating health. Pollution, climate change, and overfishing are major contributors. Imagine a vast expanse of lifeless water, where once thriving ecosystems have turned into underwater deserts. The ocean floor is littered with dead and dying marine creatures, a grim testament to the severity of the problem. This is the grim reality of a dead zone, a place where life struggles to exist. These underwater deserts are spreading at an alarming rate, threatening marine biodiversity. They now cover an area larger than the United Kingdom, a stark reminder of the urgent need for action to protect our oceans. Dead zones, also known as hypoxic zones, are areas in the ocean where the oxygen levels are extremely low. These areas are often found in coastal regions where human activities are most intense. The lack of oxygen in these zones makes it nearly impossible for most marine life to survive, leading to significant ecological consequences. This lack of oxygen makes it impossible for most marine life to survive. Fish, crabs, and other marine creatures that cannot escape these areas suffocate and die, leading to a dramatic decline in biodiversity. Fish, crabs, and other creatures suffocate and die. The impact on the marine ecosystem is devastating, as these dead zones can cover hundreds or even thousands of square kilometers. The seabed becomes a desolate wasteland. Without oxygen, the once vibrant and diverse marine environment turns into a barren landscape, devoid of life. These zones form due to a process called eutrophication. Eutrophication occurs when excess nutrients, such as nitrogen and phosphorus, enter the water, often from human activities. Excess nutrients, primarily nitrogen and phosphorus, enter the water from agricultural runoff, sewage, and industrial waste. These nutrients act as fertilizers for algae, causing them to grow rapidly and form massive blooms. These nutrients act as fertilizers for algae, causing them to grow rapidly and form massive blooms. While algae are a natural part of the ecosystem, these excessive blooms can be harmful. When these blooms die, they sink to the bottom and decompose. The decomposition process consumes vast amounts of oxygen, depleting the water column and creating a dead zone. The decomposition process consumes vast amounts of oxygen, depleting the water column and creating a dead zone. This cycle of nutrient pollution, algal blooms, and oxygen depletion can have long-lasting effects on marine ecosystems and the communities that depend on them. Climate change is exacerbating the problem of dead zones, areas in the ocean where oxygen levels are so low that marine life cannot survive. Warmer water temperatures hold less dissolved oxygen, making it easier for dead zones to form. This lack of oxygen creates a hostile environment for fish and other marine organisms. Climate change also alters rainfall patterns, leading to increased runoff and more nutrients entering waterways. These nutrients, primarily nitrogen and phosphorus, come from agricultural fields and urban areas. Pollution from human activities is the primary driver of dead zones. Factories and urban areas release pollutants that end up in our rivers and oceans. Agricultural runoff, laden with fertilizers and pesticides, is a major culprit. These chemicals wash into rivers and eventually reach the ocean, where they contribute to nutrient overload. Sewage and industrial waste also contribute significantly to the nutrient overload in our oceans. These sources of pollution add to the already critical levels of nutrients. These pollutants create a toxic cocktail that fuels the growth of harmful algal blooms, ultimately leading to the formation of dead zones. The result is a devastating impact on marine ecosystems and biodiversity. Dead zones have devastating consequences for marine life. Fish, crabs, and other creatures that cannot escape the low oxygen environment suffocate and die. Those that survive often experience stunted growth, reproductive problems, and increased susceptibility to diseases. The once thriving ecosystems collapse, leaving behind a barren wasteland. The impact on fisheries and coastal communities can be severe. Loss of fish and shellfish stocks leads to economic hardship for fishermen and disrupts the delicate balance of marine food webs. The ecological and economic consequences of expanding dead zones are far-reaching and demand urgent attention.